Hi everyone, it's Peter Taylor here at NASA JPL, and I'm going to be giving you a quick Euclid overview and update. So first, a few things about the Euclid organization. Euclid is a European Space Agency mission with NASA contributions. It has more than 1,500 members globally, and about 100 of these are based here in the US. The science effort is divided into about 10 science working groups, and Euclid is overseen by a board and a science team. And Jason Rhodes is the contact on both of these. So if you have any thoughts, ideas, or questions, he's a very good point of contact. Now, Euclid is going to be targeting two main cosmological probes. The first of these is weak lensing, and the second of these is galaxy clustering. So Euclid is actually two surveys, not one. There's going to be a wide field survey, and this is primarily going to be targeting that weak lensing science, but of course we'll also be able to do photometric clustering to do those 3x 2-point studies. And then Euclid will also have a deep field survey, and that's primarily going to be targeting that H-alpha line to do our spectroscopic clustering science, and this is going to go out to a redshift of about 1.8. And this is what the instrument actually looks like. So Euclid is a 1.2 meter telescope in space. The plan is to still launch on Soyuz towards the middle of 2022, and then Euclid will have a 6-year nominal mission at an L2 orbit. And here's the instrument. So the light is split by the dichroic, and then either enters VIS, the visual imager, or NISP, the near-infrared spectrometer. And these are the survey specifications, the instrument specifications here. And this is how Euclid will cover the sky over its 6-year nominal mission. So the different colors corresponds to the different years that the data is taken in the wide field survey. So the wide field survey covers 15,000 square degrees. This is essentially the entire extragalactic sky with cuts at the galactic and ecliptic planes. And then the 3 deep field surveys here and here, which are going to be used for that spectroscopic clustering science. The idea is to go wide then deep. So the idea is that you cover most of the area for the deep fields in the first couple of years and then fill out the depth throughout the remainder of the survey. And this is how Euclid stacks up against Rubin's and Roman. And I apologize for not getting the most up-to-date graphics for the other two surveys. So Euclid will cover 15,000 square degrees, median redshift of 0.9, so the same as Rubin's. It has a depth, a magnitude limit of 24.5, field of view, half a square degree, and then Euclid is going to have a broad vis band and then go into the near infrared in YJ and H. And in a little bit more detail, here is a plot of the depth, the magnitude limit, as a function of wavelength. So green corresponds to Euclid, blue corresponds to Rubin's, and red corresponds to Roman. Or I really should say the 2,000 square degree concept for Roman. And these numbers down at the bottom give the PSF width. So what we can see is that Euclid goes further into the infrared than Rubin's. It's not quite as deep as Roman, but then again, it's over a much wider sky coverage. And this is how the Euclid data will be released. So again, a launch towards the middle of 2022, followed by a 3-month commissioning period, and then it starts to take data all the way to the end of the nominal mission in 2028. And then there's going to be 3 main data releases, DR1 through DR3. So the first of these, DR1, is in 2024, and the final data release in 2029. And then in between these 3 data releases, there's going to be 4 quick releases, Q1 through Q4. And then all this data is going to be hosted by ESA. But they'll also be hosting here in the US at the Euclid NASA Science Center at IPAC, and this has a nice nested acronym, NSci, and Harry Teplitz is the point of contact for this. So if there's any data products that you think you will need to do your science, it is a very good idea to contact NSci now. And thank you very much for listening.